Okay, in this video we're going to take a look at a few properties of logarithms. There's a lot of properties of logarithms, but we're just going to take a look at these four right here. And I haven't even really told you what the property is yet, I just set up the situation. I'm going to derive each one of these properties, so hopefully it'll make a little sense why it is instead of just it is. And I'm going to use that lovely definition from the last video. Let me just write that on the top of this paper in case you need to remind yourself what that definition is while proving some of these properties. So log base b of x equals y if and only if b raised to the power of y equals x. And by the way, b, x, and y are completely arbitrary. They can be a, they can be b, they can be q. It doesn't matter. Whatever the problem wants those variables to be, they can be. All right, so log base b of 1 equals. This is a property. Let's apply this definition and figure out what this is always going to equal. So b is the base in exponential form. This is equal to something. I don't know what it is yet, so I'll just put a question mark there for that something. And the answer in exponential form is the number at the end of the logarithmic expression, in this case 1. So b raised to the power of something is 1. Regardless of what b is, actually b can't equal 0, sorry. Almost regardless of whatever b is, not 0. There was a property of exponents that anything besides 0 raised to the 0 power equals 1. Hopefully you remember that from your rules of exponents. So as long as b does not equal 0, anything raised to the 0 power is 1. So this property of logarithms, log base b of 1, as long as b is not 0, will always be 0. So that is a property of logarithms. Log base a of a. Well, what is that always going to equal? It's going to always equal something because that's a property that we're trying to figure out. So let's go back to this definition here and figure it out. So the base in exponential form is the subscript in logarithmic form, so that's just going to be a. Okay. The exponent in exponential form, that is what the log is set equal to, so we're trying to figure that out. And then the answer in exponential form anyways is the number or letter at the end of the log expression, so in exponential form. So a raised to what power equals a? Now hopefully you guys remember from your exponent rules, something raised to the first power is just itself. So because this question mark will have to be the number 1, any log base of that same number base will always equal 1. Let us take a look at, oh yeah, so this is a property. That's a property. That's the end of the property. Let's take a look at these two. Both of these are effectively going to be equivalent. They look a little different, but we're going to get the same result. Here I have log base some number a of that same number a raised to the power x. So we'll consider this definition again. We'll rewrite this log expression as an exponential expression, and hopefully it will be as clear as an unmuddied stream what this log expression will end up equaling. So the subscript a is the base in exponential form. That is the thing that is being raised to the exponent. The answer in log form is the exponent in exponential form. We don't know what that is, so I'll just leave it as a question mark right now. And then the expression at the end of the log is this x. That's the answer in exponential form, so a to the x. And when I rewrite it like this, hopefully it should be pretty obvious. A raised to what power equals a to the x? Well, question mark equals x. So we'll derive a little meaning of that back here in this log property. If you have the logarithm of some base of that same base raised to some other exponent, this whole expression is the exponent itself. And because of the definition of what logarithms are, this is asking you, what is the exponent a is raised to equal a to the x? And when you phrase it like that, then it's fairly obvious. It's just plain old x. This guy here is actually kind of the same thing, but slightly different. This one is in exponential form already. So use a little trickery here and convert this guy that's kind of in exponential form already into the logarithm form. So we have log base a of something equals log base a of x. Once again, the exponent in exponential form is on the other side of the equal sign in log form. And when you write it like this, it hopefully becomes pretty obvious. Log base a of what equals log base a of x? Well, question mark equals x. So, properties of logarithms. Fun, fun, fun. All right, last one here is the one-to-one property. Log base a of x equals log base a of y. What is the situation that would make this true? Using the definition, once again, let me just convert this real quick. So a raised to some power equals x. And then on the other side of that equation, I have a raised to some other power. We should have thought this through. Came up with some arbitrary variable. Equals y. Actually, I didn't really need an arbitrary variable because the exponent, these two things are equal to each other. I don't need some variable r. I'll just use question mark again. So a raised to some power equals x, and a raised to that exact same power equals y. Well, if these guys equal each other, that would only happen if x equals y. So, if we have this scenario, then we can conclude that the thing at the end of this log expression is equal to that. So, we have our little if and only if arrow once again. So there are some lovely properties. We'll zoom out. Oh, hey, Mr. P.
Oh, yeah.
And I'll do some examples in the next video.